Hi, this is Earth Science teacher Tim Martin, and in this astronomy video, I want to go over some of the debris of the solar system. Earlier videos, we've discussed terrestrial planets, Jovian planets, the moons of those planets. In this video, I want to talk about some of the leftovers: asteroids, Kuiper belt objects, and comets. There are several groups of objects that are referred to as asteroids. These are small rocks left over from the formation of the planets in the solar system. They come in two main groups. There's the group that's known as the main belt, and you can see from the diagram these occupy a zone between the orbits of Mars and Jupiter. There's another group, particularly interesting, known as the NEAs, the near-Earth asteroids. These asteroids have orbits that occasionally cross the path of Earth's orbit. It will be a bad day if one of these larger asteroids ever is at the same point in the orbit that the Earth is. There's also a smaller group that's kind of interesting. There's a gravitational balance point between the gravity of Jupiter and the Sun, both in front of and behind Jupiter in its orbit. There's a cluster of asteroids in these zones, and these are known as Trojan asteroids. Let's take a look at a few of these. Of the main belt asteroids, Ceres and Vesta dominate the field. Ceres is nearly 1,000 kilometers in diameter. It's large enough to be round, therefore it's classified as a dwarf planet. Vesta, the second largest asteroid, is 570 kilometers across. It's more of a potato-shaped rather than round. Both of these asteroids have a rocky composition. They were also both visited by NASA's Dawn spacecraft. A few of the other asteroids: Cleopatra is an interesting one that's basically the shape of a dog bone. The asteroids Ida and Gaspra were both studied by the Galileo spacecraft on its way to Jupiter. As it flew past, we discovered that Ida had its own small moon at 1.5 kilometers across. In the lower left, we can see the asteroid Eros. Eros is a near-Earth asteroid that is 34 kilometers long. It was visited by NASA's Near-Earth Asteroid Rendezvous, or the NEAR spacecraft. Two other interesting asteroids are significantly smaller, Ichikawa and Bennu. Both of these are about 500 meters across. They both were selected as asteroids for a sample return mission. JAXA, the Japanese space agency, visited Ichikawa, and NASA has visited Bennu and planned to return samples of these asteroids back to Earth to be studied. As it turns out, both of these asteroids fit the category of a rubble pile. They're not solid objects, but rather many small fragments that are loosely bound together with gravity. As we talk about asteroids, it's worth noting that Phobos and Deimos are also likely asteroids. They probably were main belt asteroids that got too close to Mars in their orbit. Instead of orbiting the Sun, now they orbit Mars. Beyond the orbit of Neptune, we find another grouping of material. This is known as the Kuiper belt. There are many objects in the Kuiper belt. The largest is Eris. Quaoar, Sedna, and Pluto also are Kuiper belt objects. You'll notice that both Pluto and Eris have highly elliptical orbit. Eris gets as close to the Sun as 38 astronomical units, but sometimes it's as far as 98 astronomical units. On the other hand, Sedna is the object in the solar system with one of the most circular orbits, and it stays approximately 90 astronomical units from the Sun. Similar to the moons of Mars being captured asteroids, Triton is likely a captured Kuiper belt object. Because of its retrograde orbit, we believe Triton passed too close to Neptune in its orbit, and instead of orbiting the Sun, it began to orbit Neptune. Pluto is likely the most studied of all the Kuiper belt objects. In 1996, this was the best image that we had of Pluto. Actually, it was more of a light intensity map than it was an image. We can barely see any detail. In 2015, the flyby of the New Horizons spacecraft changed all of that. Now we know Pluto and Charon are a dynamic binary system with tall mountains, impact craters, smooth, ice-covered plains, and many other interesting features. Here we can see some of Pluto's mountains and unique wrinkled terrain. We can also see Pluto has a complex, layered atmosphere. In 2019, the New Horizons spacecraft also flew past Ultima Thule, the most distant Kuiper belt object visited by a spacecraft. This image reveals its snowman-like structure. Well, we at least thought it looked like a snowman until this image. Due to the position of the stars, we realized that those lobes of Ultima Thule are not spherical. Ultima Thule is likely more of a flattened snowman. This graphic helps us get a perspective of the size of many of these Kuiper belt objects. On the right, we can see the Earth, and in the center, Earth's moon. You can see Pluto, Charon, Eris, and Sedna are all significantly smaller than the Earth's moon. I also put Ultima Thule on this image, but it is not to scale. It's too big. Finally, a word about comets. Here's some images that I took of the comet Pan-STARRS back in 2013. Unfortunately, it's been a number of years since there's been a bright comet that's been visible in the northern hemisphere. So, looking at a few historical images, in the picture on the left, Comet McNaught streaked across the southern hemisphere skies back in 2006. In 1976, Comet West illuminated the skies with its brilliant tail. So, what is a comet and where do they come from? We can learn a little bit about comets from this video from the Solar Heliotropic Observatory. Here we can see Comet Neat as it's swinging past in its orbit around the Sun. Notice the tail. Again, an animation may help us understand a little more about comets. For most of the comet's orbit, it remains unseen. As it approaches the Sun, it grows a tail, but then as it retreats from the Sun, the tail disappears. Comets have highly elliptical orbits. Sometimes they're very distant from the Sun, sometimes quite close. They have a nucleus of rock and ice, similar to many of the other objects deep in the solar system. A lot of times we refer to them as a dirty snowball. They have a lot of water ice, some rocks, maybe a little bit of carbon dioxide ice, and a few other organic compounds. Coming from the Kuiper belt or other areas deep in the solar system, as it nears the Sun, it warms up. The ices begin to sublimate, and debris falls off. The debris forms the tail, and the solar wind, or the outward pressure of particles coming from the Sun, push those comets away from the Sun deeper into space. So the tail doesn't follow the comet, the tail points away from the Sun. We have sent spacecraft out to visit some comets, and here are some photographs of some comet nuclei. Comet Wild 2 was visited by the Stardust spacecraft. Tempel 1 was visited by Deep Impact, where we actually blew a hole in the side of the comet to understand what comets are made out of. The European Space Agency sent the Rosetta mission and the Philae lander to 67P Churyumov-Gerasimenko. From these images, we can see comet nuclei have very different surfaces. Finally, one more comet to speak of, Comet Shoemaker-Levy. As it was entering the solar system from deep in space, it passed a little too close to Jupiter. So rather than orbiting the Sun, it began to orbit Jupiter. Jupiter's strong gravity broke Shoemaker-Levy up into many smaller pieces. Scientists were quickly able to study the new orbit of the comet and predicted that it would crash in the summer of 1994. I remember taking the telescope out that night, looking at Jupiter, not expecting to see anything. Boy, was I surprised. Although the comet impacted on the backside of Jupiter, as Jupiter rotated, we could see the impact sites. Large dark features and holes in Jupiter's atmosphere were clearly visible. Jupiter is 11 times the diameter of Earth. Several of these holes in Jupiter's atmosphere are bigger than our entire planet. Had this comet impacted Earth rather than Jupiter back in 1994? Well, I for one wouldn't be making this video. If you'd like to know more about impacts on Earth, I'd encourage you to watch my impact video. Thanks for watching, and I hope to see you again on another astronomy or earth science video.